Okay, this is Mr. Peterson, and this is the notes for Algebra 2, Section 2.3a, factoring special case expressions, okay? And we learned how to pull out a greatest common factor on the last video, page 2. So the next thing we're going to learn how to do is factor perfect square trinomials. And I'm going to start by just introducing the idea of perfect squares. So when you were in Algebra 1, when you were in elementary school, you learned your multiplication tables and probably all the way to 12 times 12. So I'll just illustrate with a few examples here. 1 times 1 would be 1. The diagonal of that chart, 2 times 2 is 4. These are called the perfect squares. 3 times 3 is 9. 4 times 4 is 16. And this list goes forever. 25 would be the next one, since that's 5 times 5. You probably learned up to 12 times 12, which is 144. And I would like to maybe extend that a little bit. 13 times 13 is 169, and when you go to 14 times 14, it turns it around, 196, and 15 times 15 is 225. Now this one is in the list, and it's a perfect square because it's 9 times 9. We could write that with an exponent. This one here is a perfect square. It's 11 n to the third times 11 n to the third. You're probably familiar with the 11 times 11 to give 121, but here you have n to the third times n to the third would be n to the sixth. N times n times n times n times n times n is n to the sixth. And with an exponent, that would look like this. And my goal here is to get you to factor this type of problem. Now, I'm going to go ahead and give you the answer here, but then I'll train you on how to do this. It's actually not too bad. You're going to go 5x minus 6 and 5x minus 6. And that would be 5x minus 6 with a second power on it. Now, I will show you that this actually works here. If you multiply first times first, you get 25x squared. Last times last, negative 6 times negative 6 gives 36. And in the middle, you get negative 30x and negative 30x, which is negative 60x. Now, I haven't really trained you on how to do this. I'm just trying to get you with the idea in your head. Okay, the next thing I want you to do is learn how to recognize these type of problems. So what I'm going to do here is highlight the perfect squares, and these problems always have perfect squares on both ends. So you're going to look for that. This is 3x times 3x. This one is 4 times 4. This one is 6x times 6x, and this one's 7 times 7. This one is 5x times 5x, and this one is 1 times 1. And so all of these pass that test. They got perfect squares on the ends. I'm highlighting them in orange here. Okay, so the next thing I want to do here is teach you how to look at the middle term and what to look for there. The middle term is either 2 times or negative 2 times the product of the square roots of those n terms that I highlighted. This was 3x times 3x, and this was 4 times 4. If you take 3x times 4 and then double it, you get 24x. You can have the negative version in the middle also. So this works out. Let me give you another example here. The square root of this is 6x. The square root of this is 7. When you multiply those, you get 42x. Doubling it gives 84. So the middle term's correct. Same thing here. This is 5x times 5x. And this is 1 times 1. If you multiply those together, you get 5x, and doubling it gives 10x. You can have the negative version in the middle too, so the middle term works out. Okay, so these are not perfect square trinomials. we have a perfect square up front. That's 2x times 2x. But 5 is not a perfect square. We have a similar problem down here. We have this one being 1x times 1x. But that negative 9 actually is not a perfect square. You can't take 3 times 3 to get this, and even negative 3 times negative 3 times itself doesn't work. So that's not a perfect square. Perfect squares are positive numbers. And maybe you remember when I showed you this, those were all positive numbers. Okay, now this next one has perfect squares on the ends. That's not a problem. Those are actually perfect squares. So it looks really like this one might be a candidate. But if you take the square root of this, you get 2n, and the square root of this is 5. When you multiply those 10n and double it, you should have a 20n in the middle, or maybe a negative 20n. So this is the wrong middle term. Okay, so sometimes I disguise perfect square trinomials with a common factor. And if you view the previous video, which you should have done, you know that you should always look for common factors first. Pick on the little guy, in this case the 5. The biggest number you can that goes into 5, well, there is only one number that matters that goes into 5. 5 goes into itself. And if 5 goes into these, we're dealing with a common factor here. The biggest common factor here is 5. And if you pull it out, you're going to have a 9x squared here. There's your 45x squared when you distribute. And then minus 6x there. You can see that those multiply to give this negative 30x. And then plus a 1 down there. And sure enough, when you distribute there, you get your 5 back. Now, we have a perfect square trinomial inside here. This is a perfect square. This is a perfect square, and let's make sure the middle term works out. That would be 3x. When you multiply 3x times 3x, you get this one. When you multiply 1 times 1, you get that one. And if you double that, you get 6x. Actually, you have to multiply by negative 2 to make it work, and you get negative 6x in the middle. But nevertheless, it works. You can either multiply that number times either 2 or negative 2 to get the middle. Okay, so now I'm going to shift gears, and I'm going to show you how to actually factor these. So I've got 3 problems, one right here, and then I'll have 2 more of them on the next video, page 4 of this note set. Okay, so first priority is what we always look for first. Factor out any greatest common factors. Actually, any common factors, but you want to pull out the biggest possible. Once you've got that, you don't want to lose it as part of your answer. So I look on this problem down here and I say, okay, pick on the small guy. The biggest thing that goes into 12 is 12, and 12 doesn't divide into 75. So I pick the next biggest thing, which would be 6. 6 goes into 60, but not 75. So then I move down to 4, and 4 works here, but not there. So then I pull out a 3. And 3 does go into all of them. So I'll pull out a 3 and figure out what that gives me here. Well, I need 3 times 4x squared to get my 12x squared right back. So you can divide here if that helps you. Negative 60 divided by 3 is negative 20. And you need an x so that that multiplies correctly. And then across the back here, you need a plus 25. And 3 times 75 gives 3 times 25 gives 75. So now what I look at here is I got perfect squares on each end, and I'm just going to see if this works here. The square of this is 2x, the square of this is 5, 2x times 5 is 10, doubled. Yep, it works. So I'm going to finally show you how to finish this off here. Okay, what you're going to use is the square roots of the end terms. This is 2x times 2x. The other one is 5 times 5. That part's done. And the sign of the middle term, right here, minus and minus. And let's multiply this out to see if it works first. 4x squared times 3 gives that. The back is negative 5 times negative 5, which is 25 times 3 gives 75. And then we have a minus 10x on the inside and another minus 10x on the outside, and minus 20x altogether times 3, and everything works. Now the final thing is you rewrite as a perfect square, and that just means you're going to use an exponent to write this. So don't lose your common factor as part of your answer, but because this factor is repeated times itself, you go like this and use an exponent to express it. Okay, and that does it for page 3. We're going to have 2 more examples like this on the next page.